Ladies and gentlemen, welcome to yet another lesson of circle geometry with me, of course, Mr. M. So on this lesson we are actually going to tackle the corollary of theorem 2, or the theorem that correlates or was born because the theorem 2 existed. That is just basically that, ladies and gentlemen. No formal proof will be done on this theorem, so we're just going to show you what it actually says. It says that the angles in the same segment, they are equal in size. So this is just a summary. An angle in the same segment, they are equal in what? In size. Now listen, gentlemen, the textbook that I once used in high school was Mind Action. So you can just go there and page it through, read it through it, and then you'll be sorted on this theorem, just for you to just know the theorem as a whole. So I don't care about the theorem as a whole, I just took this part because that's what you're going to need. Angles in the same segment, they are equal in size. So what do we mean by the segment? We have said that a segment, I'm not sure if I've tried to explain it on them on the terminology. I have said, if I did not, I'm sorry, that the segment is actually the same part. It's just like the same part, the same side. So after the center actually cuts the circle into two segments, right? So we say, yes, we have mentioned the segment when we've spoken about the minor segment and the major segment. So if we're having a center here, we say in the center will now divide our circle into two segments, or this part now divides our circle into two segment. So right, so because these ones are in the same segment, we are saying this is angle x. If this one is angle x, because it's in the same segment as this one should also be angle x. Are we okay? So if this one is angle y, this one will also be angle y. So normally, for you to be able to identify this theorem, you will actually have to think of what? Of a bow tie. I think it's a bow tie. So if you think of a bow tie, you will be able to identify this theorem. It is known as the bow tie theorem or the butterfly theorem, depending on what you like or what you can easily remember. So if you say it's a butterfly theorem, you know the wings of the butterfly, they carry the same size, and the wings of the other side of the butterfly, it's also the same size. You see here I'm saying x and x. I did not say x, 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 because this angle, it's not equal to this angle unless here we have a center. Are we okay? If we had a center here, yes, that would apply. But because this is not actually a center, and this theorem normally it is asked apart from the center, so you won't need a center to actually answer to this theorem. Hope you understand. So this will not be the center in your exam. Just state it in your mind. This will not be a center, and this theorem does not apply when there's a center only. Oh, it does not apply when there's a center only. It always applies as long as it forms like what? A butterfly rule or a bow tie rule. Hope you understand this is equal to this and not the other way around. Are we okay? So that was it, ladies and gentlemen. On the next lesson, we are going to explore the fourth theorem, where it says that the opposite angles of the cyclic quadrilateral are supplementary. I need you to hold this keywords to say it's cyclic quadrilateral. What do we mean by cyclic quadrilateral, and what we mean by supplementary? And with that being said, we'll see you on the next lesson. Please subscribe for more lesson videos. Thank you for watching. Bye, danke.